Hello viewers, welcome yet to another math lesson for the upper basic level. And again, this lesson is targeting the grade 9, but of course the other grades can also learn from it. Now in our previous lesson, we have looked at the sides of a triangle to try to determine whether they can form a triangle. We have gone through examples in that, we have done it practically as well. I hope you remember that. Now today we are looking at the triangle sum property. Okay, the triangle sum property. Now the triangle sum property says the sum of the angles in a triangle is always equal to 180 degrees. Okay, so the sum of the angles in any triangle, whenever you add the angles of a triangle, your answer is always going to be 180 degrees. Now remember, a triangle is not only three-sided, but actually it also has three angles. These are all angles here, okay? So if this is angle A, and this is angle B, and this is angle C, what we are saying here is that whenever you add A, B, and C, the sum should always be 180 degrees. It does not matter what type of triangle it is or the size of the triangles. For all triangles, whenever you add the three angles, you always get 180 degrees, okay? So, you can see here, if you add up 32, 91, and 57 degrees, that should give you 180 degrees. If you add 32, 91, and 57, that should give you 180 degrees. And the way you can prove this up is, if you attempt to draw a triangle of 91 degrees here correctly, 32 degrees, and then 57, if you cut these angles off, 91 degrees off, you cut this other angle off, and you cut this other angle off, if you fix them together, they will give you a straight line, okay? And from our knowledge of angles, we know that angles on a straight line always add up to 180 degrees. So, therefore, also you can also conclude based on that here, that since these three angles can form a straight line, so if you add them up, you should get 180 degrees, okay? Now let's see if you can use that knowledge to determine if these sets of angles form a triangle, okay? The first one we have is 30 degrees, 60 degrees, and 90 degrees. And the proof is easy. We simply add them up. If we get 180, then we are okay, it's a triangle. If we get anything else, then it is not a triangle, okay? So let's see this. We have 30 degrees here. We want to add that to 60 degrees and add that to 90 degrees and see what our sum is going to be. If you add this, of course, if you add all this bunch of zeros here, they only give us 0. Okay? Now, when we add 9 plus 6, that should give us 15. And 15 plus 3 should give us 18. So that gives us 180 degrees. And that is exactly what we want, all right? We want our sum to be 180. So since the sum here is exactly 180, we can conclude that these three angles can definitely form a triangle, okay? Because their sum is exactly 180. Then we can use the same process to check for the remaining angles. Next one we have is 120 degrees, 32 degrees, and 48 degrees. Let's see whether if we add them up, our answer will exactly be 180. So let's see. This is 120 added to 32, and we add that to 48. So if you add this up, what we get is 8 plus 2 should give us 10. That's a 0 with a carry 1. Now 1 plus 4 is 5. 5 and 3 should give us 8. 8 and 2, that should give us 10. That is 0, and you should carry 1. And then 1 plus 1 is exactly 2. But that's 200. And what we want is what? 180. So we can conclude based on that that these three angles do not form a triangle because their sum is not equal to 180 degrees. So they don't form a triangle. Now let's try the rest. The next one we have here is 35 degrees, 55 degrees, and 100 degrees. We want to add them up. If the sum is exactly 180, it's a triangle. Anything else is not a triangle, okay? So let's see. 35, 55, 100. If you add that up, that is going to give us 5 plus 5 will be 10, 0 carry 1, 1 and 5 is 6, 6 and 3 would give us 9, and then this one comes down. We get 190 degrees. But is that what we are looking for? No, it is not. What we really want is 180. And this is not giving us 180, so we can say therefore that 35 degrees, 55 degrees, and 100 degrees do not form a triangle because their sum is not equal to 180. And we can test now for the last one. And here now we are given 100 degrees, 23 degrees, and 57 degrees. We're going to add them up and see. If we get 180, it's a triangle. If we don't get 180, it's not a triangle, okay? So 100, 23, 57. You add this up. 7 plus 3, that will give us 10. 0 and carry 1. 1 and 5 will give us 6. 6 plus 2 should give us 8. And then we bring down the 1. And what do we get? We get exactly 180 degrees. And that is what we wanted, all right? So we can conclude that, okay, 100 degrees, 23 degrees, and 57 degrees form a triangle. These are the angles of a triangle. Why? Because their sum is exactly 180 degrees, okay? This was just a confirmation here that when we added these three angles, we got 180, so we say, yes, it's a triangle. We added up these other angles, we got 200. No, it's not a triangle because 200 is not equal to 180. Then we added this other 3 here, and we got 190. And that's again not a triangle. No, because 190 is not equal to 180. And this is just confirmation that when we added the last one, we got 180, and that's equal to 180. So yes, those angles form a triangle. Now this is for you to determine now. A triangle could have which of the following sets of angles? We have 40 degrees, 90 degrees, and 105 degrees. Then you have 35 degrees, 89 degrees, 56 degrees. Then you have 75 degrees, 90 degrees, 15 degrees. Then you have 30 degrees, 65 degrees, and 95 degrees. Now, which sets or set here will give you a triangle? Maybe all of them, maybe none of them, maybe 1 or 2 of them. Let's see which. We're going to investigate all of them. The first one we have is 40. Let's add them up. 40, 90, 105. So if you add this up, will we get 180? That's the question. Add this up. 5 plus 0 is just going to give you a 5. If you add 9 plus 4 is already 13. That is 3 and carry 1. And 1 will give you 2. 235 degrees is not equal to 180. So this one doesn't form. So you can take that out. So we know this one? No. They don't form a triangle, okay? Now let's try the next set. And the next set we have is 35 degrees, 89 degrees, and 56 degrees. Let's see. 35, 89, and 56. You add this up. 6 and 9 is 15. 15 and 5, if you add that up, that gives you 20. 0 carry 2. 2 and 5 should give us 7. 7 and 8 should give us 15. And 15 plus 3, it will give us 180. Very good. So that gives us exactly 180. And that is what we're looking for, okay? So those ones, they form a triangle. So we can take this off. And with this one, let me use a different color. Okay. Let's say we give it a green tick. Okay. Then let's take for the next set. We now have 75 degrees, 90 degrees, and 15 degrees. Okay. Let's add them up. 75, 90, 15. If you add this up, 5 plus 5 will be 10. 0 carry 1. 1 and 1 is 2. 2 plus 9 is 11. And 11 plus 7 will give us 18. Again, that's exactly 180 degrees, which is what we are looking for. So this also is correct. Then we take the last one. Let me rub this off. Okay. The last one is 30 degrees, 65 degrees, and 95 degrees. Let's add this up. Now, 5 and 5 will give us 10. That is 0 and carry 1. 1 and 9 would be 10. 10 plus 6 will be 16. 16 plus 3 will give us 19. That is not equal to 180. It's 190. So this one will get a red cross out. So in the end, the only two that give us a triangle is Roman figure 2 and Roman figure 3. And yes, that means B. That is Roman figure 2 and Roman figure 3 only. Those are the only two that gives you angles that you added up and you got 180. So those are the only ones that can form a triangle. Here's another set to try with. 37 degrees, 63 degrees, and 80 degrees. Now let's see if you can add them up and let's see what we get. If you add this first one up, let's start to add it up and see. Let's add the units. That is 0 plus 3 is 3. 3 plus 7 is 10. That is 0 and carry 1. Then 1 and 8 is 9. 9 and 6 is 15. 15 and 3 is 18. So what do we have? 180 degrees. So green tick works. The next one, we are adding up 76 degrees, 104 degrees, and 90 degrees. Let's add them up. First add the units together. This will give us 6 plus 4 is 10. 10 plus 0 is still 10. So that is 0, carry 1. Now 1 and 7 is 8. 8 and 0 is still 8. And then 8 plus 9 is 17. That is 7 and carry 1. Then 1 plus the 1 here That will give you 200. 270. Again, 270 is not equal to 180. So you can take that off. Not a triangle, okay? Then we move on to the third one, 23 degrees, 47 degrees, and 50 degrees. If you add them up, see what we get. 0 plus 7 is 7. 7 and 3 is 10. That is 0 and carry 1. 1 and 5 is 6. 6 plus 4 is 10. 10 plus 2 is 12. That gives you 120 degrees, which is not equal to 180. So that's also out. That leaves us with 80, 90, and 10 degrees. If you add this up easily, 10 plus 90 we know is 100. 100 plus 80 is 180. And that is what we are looking for, 180 degrees. So we can give this also a green tick. All right? So it was only 1 and 4 that give you triangles, and we can circle that here, 1 and 4 only. Those are the only ones that can give you triangles because they sum up to 180. The rest don't. Now, still on the triangle inequality, we say the triangle inequality property can also be used to determine the range or set of possible values for the third side of a triangle. All right? So we can use the triangle inequality property to try to determine the range or the set of possible values for the third side. Okay? Consider a triangle with sides of length 4 centimeters and 6 centimeters. Can we predict the possible side lengths of the third side? Okay? So here we have only been given 2 of the sides. Now I want to find a way that we can predict the possible lengths of the third side. Okay? That's something we need to think about. And let's see if we can actually get it. Now consider a triangle with side lengths of 4 centimeters and 6 centimeters. Same question, can we predict? We want to be able to predict the possible side lengths of the third side. We want to be able to predict that, all right? Now we actually can do that using the triangle inequalities for the side lengths given. Now, let's look at it slowly. We have been given 4 centimeters and 6 centimeters as the first 2 sides. We want to predict the possible lengths of the third side. Okay? So what we do is, remember we said that if you add the 2 shorter sides of a triangle, your answer should be greater than the longer side or the third side. Yeah? So if we add 4 plus 6, our answer should be greater than the third side. Okay? And adding 4 and 6 will give you 10. So we are saying now our third side has to be greater than 10. That's important. Okay? We know this, that our third side has to be greater than 10. Next, we need to consider when a shorter side is known. All right? Now, let's take the first shorter side. Okay? So now if you take the first shorter side plus our third, remember the third is the longer side in this case here, so the shortest, one of the shorter sides plus the third side should give us a sum which is greater than the remaining side. Meaning, this 4 plus the third side, which we don't know yet, if you add them up, our answer also has to be greater than 6. That's this third side here. Now when you get that, for you to add 4 and a number and get something less than 6, simply means your third side has to be greater than 2. Because otherwise, you will get something less than 6. All right? Say if you add 1 here, 4 plus 1 will only give you 5. So for you to get a side greater than 6 here, you must add the third side here has to be greater than 2. So look what we had here. We first said that the third side has to be greater than 10. Again, now we are saying the third side still has to be also greater than 2. Now, we need to put these two ideas together as one inequality. Okay? And we can actually do that. The third side must be greater than 2 centimeters and less than 10 centimeters. Okay? Because the sum of the two sort of sides is greater than the third side, which means the third side is less than that. Okay? So if the third side is less than 10, but the same third side is greater than 2, if we put that up to as 1, what you have is, assuming that our third side is x, okay, that x has to be less than 10. All right? But that same third side has to be greater than 2. So that becomes your inequality. So we know, therefore, the possible length of the third sides is in that range, greater than 2 but less than 10. It has to be within that range. It could be probably 3 or 4 and so on, but has to be greater than 2 but less than 10. That predicts our possible third side. Now here's another example. Predict the length of the third side of a triangle with sides of length 12 centimeters and 16 centimeters. We have side 1, 12 centimeters. Side 2, 16 centimeters. Okay? The third side must be less than the sum of these two sides. So assuming that the third side is x, it has to be less than the sum of 12 and 16. And that will give you the third side. If you add 12 and 16, that should give you 28. So the third side has to be less than 28. 1. Okay? So we have added the two the two given sides, and we know that sum has to be greater than the third side, meaning the third side has to be less than their sum. So the third side has to be less than 28. We keep that. Now, if you continue, let's see. If we now take the 12, the first side here we given was 12. If we now take 12 plus the third side, which we don't know, is x for now, that has to be less than the other side, which is 16. I'm just taking the 12, the first side here. So it means here 12 and the third side should be less than 16. So for this to be true, all right, for 12 plus a particular number to be greater than 16 rather, what does that tell you? The third side must be greater than 4. Because if you put any number less than 4 here, you don't get a sum which is greater than 16. But if you take any number greater than 4 and fix it here, if you add it to 12, you will get a sum which is greater than 16, which is what you want. For example, you fix 5 here, 12 plus 5 will give you 17. And 17 is greater than 16. So therefore here, this third side has to be greater than 4. Good. So now all we do is, we need to combine this. X is less than 18, and this here, x is greater than 18 as one inequality. All right, to predict our possible third side. That means If put x, x is my third side, then that x has to be less than 28, like that, but greater than 4. So that becomes my inequality, all right? So the range where my third side can fall is a number which is greater than 4, but less than 28. That is the range, all right? That's the range of the possible values of the third side here, okay? Right. Now we still continue. Predict the length of the third side of a triangle with sides of length 9 centimeters, 15 centimeters. Okay? Again, let's try the same process. Okay? Assuming that our third side, again, is x. Okay? If we add these two sides, our answer has to be greater than x. All right? Meaning 9 plus 15 has to be greater than x. And if you add 9 and 15, that should give you 24. 24 has to be greater than x, which means x is less than 24. Right. So from there, we know one condition that our third side would have to be less than 24. One condition met. Then now, if we take the first side, that's 9, plus our third side, which is x, remember, that again has to be greater than the other side there, which is 15. Now, for this to be true, what can you possibly put here? All right, for you to 9 plus a number, that's our third side, being greater than 15. So what are the possible values I can put here? I must put a value here that if I add it to 9, I will get a sum which is greater than 15. So based on that, our x or our third side here will have to be greater than 6. All right? So we can say, therefore, x has to be greater than 6. Because otherwise, you don't get a number greater than 15. Okay? Because now, even if you put 6 here, 9 plus 6 will give you exactly 15. So that will not be correct. But any number bigger than 6 will work. 7 will work. 10 will work. So, what do we know? Our third side has to be less than 24. It also has to be greater than 6. You put those two together, and you will get the fact that our x, the third side, is less than 24 there, but that same third side is greater than 6. So that again gives you the range of the possible values for the third side. All right? Has to be less than 24 but greater than 6. Okay? There. Now I want you to go ahead and try this. Try to determine if or predict the length of the third side of a triangle whose known sides are 13 millimeters and 20 millimeters. Let's start with that, okay? We want to see, I want to predict or find the range of possible values for our third side here, okay? Remember, what do we do? First, let's represent our third side with a variable. Let's say our third side is x. So if the third side is x, okay? Now, if you add these two known sides, your answer should be greater than that third side. So when you add 13 and 20, you should get a sum greater than the third side, x. Then that gives you 13 plus 20, which is 33 greater than x, which means also our x has to be less than 33. So now we know one condition, that our third side will have to be less than 33. That's one condition met. Then now, let's take the first side, that is 13. 13 plus the third side again has to be greater than 20. Okay? 13 plus the third side has to be greater than 20. Again, then we are mindful of what number can we put here, what's the lowest number we can put here, so that our answer has to be greater than 20. And that we know here x will have to be 8 or greater, all right? So our x here cannot be less than 8. Because if you put any number less than 8 here, you will not get a sum which is greater than 20. Okay? So from there, we know therefore our x has to be greater than 7. All right? It has to be greater than 7. Because you put 7 there, you get 20, which is equal. You put any value less than 7 here, you even get a smaller value. So here our x has to be greater than 7. Remember, x is the third side. So look what we have now. Our x has to be greater or less than 33. The x, that's the third side, has to be greater than 33. Then the same third side, what did I say here? Our third side has to be less than 33. And then the same third side has to be greater than 7. Now you put these two together, then what do you have? You have our x, that's the third side, has to be less than 33, that way, but it has to be greater than 7. So again, that range gives you the possible values for our third side. It doesn't give you the exact value, but we know our third side will fall within that. A number greater than 7, but less than 33, okay? Then we can do the same thing for 7 and 19. Let's investigate. Or let's try to predict our third side. Now yet again, we assume that our third side is x. We know that if you add the given sides, our answer has to be greater than the third side. Okay? Meaning, if you add 7 and 19, that has to be greater than the third side, which is x. Okay? And when you add this, you get 26. 26 has to be greater than our third side x, which means our third side x has to be less than 26. That's one condition. So we know here, from here now, that our third side has to be less than 26. Then, next, if we take the first side, 13 plus the third side, nope, not 13, did it? Okay, the first side is actually 7. If we take 7 plus the third side, which we have chosen x to represent, that has to be greater than this 19. Okay? Then we can now see what values can we put here, because 7 plus the third side has to be a number greater than 19. All right? Which means whatever number we put here, it has to be greater than what? That will be 12. It has to be greater than 12. Because if you put 12 here, what do you get? 7 plus 12 is 19. You don't want that, all right? So your x has to be a number greater than 12. So our third side is definitely greater than 12. That's for certain. Any number greater than 12 here will satisfy this. Okay? So, again, let's put this together. We have x less than 26. We have again the same x greater than 12. You put those two together, you end up having x, the start side, has to be less than 26, but greater than 12. So again, that gives you the range of possible values of x, or our third side, because x represents our third side, okay? And this was just illustration of what we have just done right now. Right, you need to try this now. Okay? 4 centimeters, 11 centimeters. Try to predict the possible length of the third side, which we know is easy. You add the two given sides, your sum should be more than or greater than the third side. So if the third side is x, then 4 plus 11 has to be greater than that x. 4 plus 11, which is 15, has to be greater than x, which means x has to be less than 15. That's one condition. Our third side has to be less than 15. Then now, take the first side, 4, plus the third side, which we have used x to represent, still has to be greater than 11. And for you to put a number here and get a sum greater than 11, it means your x here has to be greater than 7. Because you put any value equal to 7 or less than 7 here, and then your sum would be less than 11. And you don't want that. What you want is your sum to be greater than 11. So whatever you choose here, it has to be greater than 7. You can choose 8, 9, 10, and so on, okay? So then we have this first condition here. Our third side is less than 15. Has to be less than 15. The same third side has to be greater than 7. Now you put these two together, you will have third side x less than 15. The same third side is greater than 7. Again, that there gives you the range of possible values for the length of the third side. The third side, we know, is a number greater than 7, but less than 15. That's where the number lies, okay? And we have number 12, 23 centimeters and 34 centimeters. We look this up and predict or get the range of possible values for our third side. First, we know if the third side is x, as we like to call it now, if you add the two given sides, 23 and 34, that has to be greater than that third side. Now, adding this up, you get, this is 57. 57 has to be greater than our third side, which means the third side has to be less than 57. That's one condition, that the third side will have to be less than 57. Then also, if you now take the first side, which is 23, plus the third side, which is x by the way, that has to be greater than that 34. Okay? So now, what number can we put there? It means from here that whatever number we choose, it has to be greater than 11. Because if you put any number equal to 11 here, or less than 11, you won't get a sum which is greater than 34. So our x here would have to be greater than 11. Because now, let's say 12. 12 plus 23 will give you 35, and 35 is greater than 34. And you keep increasing the number, and then that sum will keep rising. Okay? So our x here cannot be, it has to be greater than 11. Now, put these things together. The x is less than 57. That's the third side. The same third side is also greater than 11. Put those two together, and you will have the third side less than 57, and the same third side greater than 11. And that gives you the range. Now, this is something for you to try. Predict the length of the third side of a triangle whose known side lengths are 6 meters and 12 meters. Okay? This is something that you should be able to do. Is it A, B, C, or D? Okay? Let's try to analyze it. First step should be you add the given sides, and your answer should be greater than the third side. So 6 plus 12 has to be greater than our x. This is 18, which means the x has to be less than 18. One condition. Okay? Then 6 plus the same x has to be greater than 12. Right? What number can I fix here and add it to, or what possible numbers can I fix here and get add it to 6 and get a value greater than 12? Simply means that our x has to be greater than 6. All right? So we now say that x has to be greater than 6. So what does that tell us? That our third side, which I call x here, has to be less than 18, but greater than 6. So now let's see which one fits this bill here. It says third side is greater than 18 meters and third side is less than 6 meters. From what we actually have is the third side has to be less than 18, not greater. So this is out. Okay? Then B says third side is less than 18 meters and third side is greater than 6 meters. And if you compare, yes, our third side was less than 18 and it's also greater than 6. So this will work. How about the C? Third side greater than 12. We never had that anywhere. So that's out. D also, third side less than 12. We never had that anywhere. So the only correct answer is C, that says that the third side has to be less than 18 meters and the same third side has to be greater than 6 meters. Again, let's try to predict the length of the third side of a triangle whose known side lengths are 15 centimeters and 43 centimeters. Let's go through the same process. Out of the given sides has to be greater than the third side. So 15 plus 43 has to be greater than our third side. And adding this up, you get 58 has to be greater than x, which means the x third side has to be less than 58. That's one condition. Our third side has to be less than 58. Then the other part is, if you now take the 15 plus the third side, that has to be greater than 43. Okay? Which means from that, for 15 plus the third side to be greater than 43, it simply means our x, or the third side, will have to be greater than 28. Okay? Our third side will have to be greater than 28. Right? Because if you put 28 here, you add that up, you get 43. We don't want that. If you take any number less than 28 now, the number actually keeps going down. We don't want that. All right? So our x in that case has to be greater than 28. So x has to be greater than 28, but x has to be less than 58. That takes out a and b. All right? So we are left with c and d. You can just cross this out because nothing mentions 15 and 43 in our answers. Now, C says 28 centimeters has to be greater than our side. Was that what we got? No. What we actually got was the start side has to be greater than 28, not less. So that's out. How about the D then? 28 less than third side. Yes, we got that because the third side is greater than 28. So that's a check. And then the third side less than 58. We also got that. So this is the only correct one, D. So now we look at this number 10 here. It says predict the length of the third side of a triangle whose known side lengths are 9 centimeters and 17 centimeters. Again, we are going to go through the same process and try to predict the possible lengths of the third side. What do we do first? Assume that the third side is x. Then we add the two given sides, and our sum of those two given sides has to be greater than the third side. So we are given 9 and 17. That sum has to be greater than the third side, x. This will give us 26 is greater than x. So 26 has to be greater than our third side, meaning our third side will have to be less than 26. That's one condition. Now let's take up the first side. We also know that the first side plus the third side has to be greater than the second given side. That is 17. So the first side plus the third side has to give us a number greater than 17. So what could be the possible values here? What can we put here? Based on this, our x has to be greater than 8. All right? Because if you put 8 here, 9 plus 8 is 17. That's not greater than 17. And if you put any number lower than 8, it even gets worse because the numbers become smaller and smaller. All right? But if you choose any number greater than 8 and you add it up here, you will get a sum which is greater than 17. So our x is greater than 8. So this is what we have. Our third side has to be greater than 8. And then somewhere, our third side has to be less than 26. That's what we have. So let's see which is correct here. This one says 9 less than whatever. Nowhere did we have 9 in our answers. So we can just rule out A and B. Because we are playing with 26 and 8. There's no 9 there. So you can just automatically rule out A and B. They're out. Now C says 8 centimeters is less than the third side. But did we have that? No. What we had was, oh yes, we did have that. 8 centimeters is less than the third side. Actually, we had that. because our third side is greater than 8, meaning 8 is less than the third side. So we had this. How about the other one? The third side less than 26. That too we had. All right? So that means this one is correct. How about D? Did we have 8 greater than our third side? No, we never had that. What we had was our third side greater than 8, meaning 8 less than our third side. So this is also out. Let me use a different color for that. That's out. So the only correct answer here is C, that 8 is less than the third side, and the third side is less than 26. So our third side here has to be a number greater than 8, but less than 26. Those are the possible values of the length for our third side here. Now with that, we come to the end of today's lesson. Till I come your way again, goodbye.